Hello, my name is Michael Thompson. I'm the CEO and founder of SkyFly Technologies, and we're building this aircraft you can see in front of you, which is the AX. It's a two-seat, fully electric, vertically capable aircraft, both in a fully electric and a hybrid configuration. So we're really targeting the private pilot markets, so personal use, and then we're doing a defense version, which is an unmanned system, and then we're looking at also doing the training market as a powered lift training aircraft, and then also emergency services using that sort of cargo capability. So hopefully this video will play. So this is our first aircraft, first airframe, if you like, serial number one. So this was designed, built, flown in the UK so far. We're just getting it over to the US today. It's just landed at New York. So it'll be on the stand from tomorrow. So we recently completed the first airfield to airfield flight of an eVTOL in Europe. So we're essentially here at Oshkosh to expand our US sales. We've got 42 paying customers already, but the majority of those are in the US, so that's why we're here today, really, to expand that order book. With the military side of things, we're making progress in the UK with the MOD, with being signed up on the Uncrewed Air Systems Heavy Lift program with the MOD. And so this aircraft is going to be certified in the US under hopefully light sport under Mosaic regulations, and then in the UK under a permit to fly. So what's the problem we're looking to solve with our aircraft? And really it comes down to what's been on the market available for the past 50 years is pretty outdated. Our closest really competitor is an R22 in terms of capabilities, vertical takeoff. And you know, that was designed in the 70s, so from a crash worthiness perspective, it's pretty outdated. They're very mechanically complex, they're extremely noisy, they're very expensive to run. For a pilot, they're relatively, well, they are difficult to fly. There's no stabilization really to help the pilot, which means there's quite a lot of incidents. Also, from an ergonomic perspective, they're quite outdated as well. So from the interior perspective, it's quite old school. So our aircraft's looking to sort of modernize this sector of vertical lift. So our aircraft, called the AX, has this unique two-wing configuration. So it's a canard layout. It's a fully carbon composite structure. Everything from the propellers to the wings to the fuselage to the undercarriage, everything's carbon. So we've got a maximum takeoff weight there of 750 kilos, including 200 kilos worth of passenger payload. So this two-wing design is unique, and it enables us to glide. So a lot of these eVTOL or vertically capable aircraft do not have that capability. So we get a glide ratio of 5:6 to 1. So that enables you to glide in the event of a full power failure. And we're actually able to do that through having mechanical control linkages to all our control surfaces. So on the canard, you've got an elevator. On the main wing, you've got ailerons, and on the fin and rudder, you've got a control there for yaw. So really, we're taking the best bits of modern technology in the flight controllers in the hover phase, but in forward flight, this is a conventional fixed-wing aircraft. So looking at the propulsion system, we've got 8 electric motors, 2 on each wing end for redundancy, so you can have a failure in forward flight of one whole corner, in fact, but in the hover we've added that redundancy for failure in the critical phases in the hover. One of the biggest things we've found throughout flight testing is just how quiet this aircraft is. You know, you've got those motors outboard, so you can have a general conversation in the cockpit without needing a headset. And also the vibration levels of this machine is uncompeted. It's incredible. So I think that as well is a whole new perspective on light aviation as it's been known since the dawn of time, because we've never really had an opportunity to have this configuration before. So going back to sort of the comparison to a helicopter, in the hover phases, it's completely, you're flying under the control of a flight controller, which stabilizes every movement. So if it's windy, the pilot isn't correcting for turbulent air, etc. So it's a lot easier to fly. Again, electric propulsion is fantastically simple and maintenance free. So your running costs for this machine are much less than a traditional piston engine fixed wing or helicopter. Finally, the wings also give it such versatile performance. We can do conventional fixed wing takeoffs on a runway, but also vertical takeoffs as well. Using a conventional takeoff, you'd use a lot less energy, so you can really extend your range. And then finally, the whole design is very technology agnostic. So the flight controller we're using for the manned side of things is exactly the same flight controller we're using for our unmanned system. So from a production perspective, we're not doubling up on having two different production lines. It's the same aircraft, the same tooling used. Is only modifications to the flight controls for it to become an autonomous vehicle in the unmanned configuration. So our aircraft has been through, we started 6 years ago, first drawing 6 years ago, and we've been through a sort of iterative design phase for about 3 years, where we built the third scale you can see on the left of the screen. So that we built maybe 3 different versions of that, design tweaks throughout, and then we locked down the design and went to full scale tooling. And then the first phase of our flight test program was hover testing, which I actually did. So we tuned the aircraft for the hover. The next phase was to do the conventional takeoff and landing, which is what you see in the bottom right corner and the videos you saw as well. So the next stage is transitions. We were meant to be doing them now, but we're in Oshkosh and our airframe is here. So we were meant to be doing them this summer, but I prioritized this event because I really thought it was one to be here for. So on aircraft performance, so this prototype is using batteries probably with cells that are maybe 10 years old in technology. So with this next airframe, we're really looking to upgrade our whole propulsion system. I mean, even with this prototype, the figures are quite respectable, given it's fully electric. So we get about 45 minutes or an hour in fully conventional fixed wing configuration, which for a non-fixed wing optimized aircraft is actually very impressive. But our production aircraft, we're going to be increasing our battery capacity up to around 270 kilowatt hours. 270 watt hours per kilogram, with 60 kilowatt hours installed on the aircraft. So with that, our range will increase significantly. And we're also going to increase the reserve factor for safe landing. So that'll be around 30% state of charge. The other upgrade we're doing is we're moving over to a different motor supplier, which will have an integrated inverter on the back of the motor. Again, we're sticking to the simple architecture of having a air-cooled motor. Everything's air-cooled. We're not doing liquid-cooled. The whole thing with this machine is simplicity, hence no rotating wings or motors, etc. So everything's air-cooled. And again, we're moving to a supplier that can deliver us the volume we need to get to for our sales order book. So I've briefly touched on the markets, but I will do so again. So, you know, there's a huge focus on eVTOL and the commercial applications for these aircraft. And we think that the private use market is really underserved. You know, there's around 800,000 pilots between us in Europe and the US. And we're really looking to take advantage of that, the market that exists today. So pilots that already have a license and hopefully utilizing the Mosaic regulations, which are going to come out hopefully this week, we'll see. That will enable us to fit into the light sport category. So yeah, the private pilot market's a big thing for us. It will also give us the ability to go to market and get hours on the airframe very quickly without having to go down the certification route that these big air taxi companies are doing. So yeah, private pilots is a big thing for us. Training organizations, so whichever big eVTOL manufacturer wins the race to getting to market first, they're talking about simulator-only training, but we also think it's very important to have real-life training in powered lift configuration. So our aircraft is a real good trainer, a two-seat side-by-side configuration. So we see it as a very, very attractive option for powered lift conversion training. Then the military side of things, So defense applications, again, we've got quite a unique capability in that we can carry around 200 kilos of payload, again, in fully electric, about 100 miles, but then a hybrid version, which we're developing, will go around 300, I think will be more near 400 miles of range, which really then puts us in real competition with helicopters. And then the emergency service side of things is sort of bolt onto that unmanned configuration. So that's anything from medivac to surveillance to all sorts of things. There is so many different parts to that, but I'll keep going for brevity. So the timeline. So where are we now, and where are we looking to get to? So we're mid-flight test at the moment. So we've done hovering, we've done conventional flight, and the next phase is transitions. But flight testing will run alongside the next airframe build. So our next airframe is serial number 2. This will be the aircraft that goes through the certification process in the UK, which is a permit to fly. In the US, again, if the Mosaic rules don't work, we can use the experimental amateur built route as well. So again, that's not a massive concern for us. We want to get aircraft sold and flying in the US as quickly as possible. 70% of our customer base, existing customer base, is in the US. So anyway, so by Q2 next year, we want to be selling aircraft. That's our goal. That's when we want that second airframe to have completed its permit to fly, received its permit to fly in the UK, and then we start delivering thereafter. So that's just a rough estimation on timings. Just want to quickly mention the team we've got. Bill, who isn't here right now, but he's our chief designer, chief technical officer. He'll be on stand 421, where the aircraft will be tomorrow morning. So really, really encourage you to come down and speak to him. Very, very clever guy. And then Sinjan, who's not here, but he's our chief operating officer. He essentially ran the Electroflight, which was a company that delivered the Rolls-Royce Axel speed record aircraft. So he's got a huge amount of experience with battery systems. Again, if anyone wants to speak to him about our new battery system, etc., please do let me know, and I'll put you in touch with him. And then the other two guys, CFO, less interesting, but all the same very important, coming from ProDrive, and then my chairman and very good friend of mine, Richard Tuthill, who's scaled his business from a very small operation in Oxfordshire to now over 100 employees. So he's been through the pains and stresses that I'm going to be going through shortly with scaling up the production for this aircraft. So we've got a really good team that's here to build this company and to deliver this aircraft for our customers. So that's it on the presentation front. Any questions? So 5:6 to 1. It's 6 to 1. Yeah, it's about in between the two of them. Oh, so sorry. So I was asked what the glide ratio is, and my response was 5 to 6 to 1.
And second question is, do you have a target price, retail price for
Yeah. So the pricing is a difficult one. We want to get as many orders as possible. With more orders comes economies of scale. Our pricing at the moment for the orders we've got is £295. So that's, but we're not beholden to that price. Any opportunity I can to reduce it, I will. But that's where we're at the moment. For example, we've got customers in Canada. We're going to work with the authorities in the same way we will with the FAA. We just due to the amount of customers we got in the US, we are focusing on that. But we do have a customer in the US, in Canada, that we will be going with through the certification process with, and it will likely be either experimental initially to get it flying in Canada, but then hopefully they will take on the Mosaic rules as well in Canada. That's my aspirations, I think. So with a permit to fly in the UK, essentially allows us to rubber stamp that across Europe. So EASA and CAA work very closely together. So the batteries are a really interesting one. Our aircraft is, so when we were looking at battery selection, we had to consider whether we wanted to go down a completely certified battery route, or we were going to go down the route of developing our own battery. and we've sort of landed in the middle. So we've landed on a module that we like, which has a very high, as you say, 270 watt hours per kilogram is a high capacity, or energy density, should I say? But what we've done, we've taken those modules and we've created our own essentially battery packs. They're individually vented, so we've solved the issues with thermal runaway and all the certification challenges we're going to have with a bit of our own IP and a bit of our own design work. As I say, our COO has come from Electroflight, where they built battery systems for lots of different large OEMs. So we know what's required from a certification side of things. But you have to remember, with a 2-seat aircraft compared to a large 5 or 6-seat aircraft, the risk and the sort of means of compliance has to be proportionate to your aircraft size. So whilst we did want to go to the same level of safety standard that a big air taxi is going to be using, it's really not appropriate for our size of aircraft, the types of operations it's going to be used for, private ownership only. It's not an air taxi. So we've used the ability we have with the permit to fly is we essentially agree the means of compliance with the authorities. So we prove to them why what we've designed is proportionate to the aircraft we built. So the aircraft is conforming to SC-VCA. So it's an EASA document, which the CAA recognise. So that's why I'm saying that whilst we're getting a UK permit to fly, that permit to fly will be used across Europe. The same means of compliance. We're not just using that document, we're referencing lots of other ones, but the basis of it is that document. And as I say, we're the bits which we can't conform with, just due to what aircraft we are, the size we are, we then take bits from CS23 or whatever it is to really get to where we want to be on a permit front. Again, the pricing is flexible. So we want to do 40 aircraft in our first year. So that's our target, yeah. And as I say, majority of those will be in the US. So actually, Bill, I forgot to mention this, we are going to be having opening a production facility in the US as well. A production facility to make parts, but also customer build centers, because it's a kit plane. So we're looking at Maryland, is the most likely option at the moment. Alta Sky, who is a company we've partnered with over here, we're working with them for that build facility and a builder assist center. Whether it goes through an EAB route or a light sport route, it's still going to be a kit plane that's built by the owner. Initially, we're not doing factory built.